Hi, I'm a Bullis Student Tutor, and in this video, I'm going to introduce you the quadratic function vertex form. So in this video, I'm going to show you the transformation of this quadratic function, and also how can you write the equation by looking at this graph. Before I go into the specific, I'm just going to show you first the formula of this function. A is the amplitude change, H is shift, horizontal shift, and K is the vertical shift. So let us begin. First, let's look at this parent function. So we can see from this graph that this function at origin is 0, and so it has no horizontal or vertical shift. And then at this point, 1, 1. So as x increases 1, y also increases 1. So the equation of this function is y equals to x squared. And this is the parent function. Keep in mind, this function will show up in every graph in the next few slides, and it will guide you as a base. Now, let's look at this function, this blue one. So, what do we notice? The difference between this and the original red function. The shift of its place. So how do we write this equation? Well, we can see from this graph that it shifts up 2 points. So in the end we add 2, and we can also see it shift to the right 2 points also. So it will be x minus 2 squared plus 2. So remember, when x minus something, this 2 is how much is shift to right, and when it plus this in the end is how much is shift up. Now let's look at the change in amplitude. So we notice this function, the green one, has the same origin 0, 0 as the parent function, which means it has no vertical or horizontal shift. However, we can see the amplitude of this function is much different than the original function. It shrinks to the center. So let's try to plot this point. So we know that this function should be y equals to ax squared, but we need to figure out what is a. So how do we do that? We first find a point. So I'm going to choose this point, which is 1, 2. And let's plug it in. So when y equals to 2, x equals to 1. Okay, so what do we get? 2 equals to 1a. So a equals to 2. So this is the amplitude of this function. So what's the entire equation of this function? Y equals to 2x squared. Now let's look at the last example, this blue function. So this function is exactly the same, except it's opening down instead of opening up. And the way we write that is that we change from the original function y equals to x squared to y equals to negative x squared. And this makes it turn from opening up to opening down. So in the last part, let us solve a difficult function which combines everything we have just discussed. First, let's figure out the shift, the horizontal and vertical shift, by looking at its vertex. So its vertex is -1, -2. So how should we write that? What is h and what is k? So y equals to ax plus 1 squared minus 2. So that's the horizontal shift, left 1, vertical shift, down 2. So, and we then find another point to find a. So let's see this point, which is 1, 0. So let's plug that in. So 0 equals to a 1 plus 1 squared minus 2. So equals to a 4 minus 2. So 4a equals to 2. And what does a equal? 1/2. Okay, so you just solve the function, which is equals to 1/2 x plus 1 minus 2. Okay, so let us recap. What do we notice here? This formula, y equals to a x minus h squared plus k. So a is the change in amplitude. Determine how tall this function is, how much it shrinks, and also if it's opening right side up or upside down. And x minus h, this h here is the horizontal shift. And plus k, this k here is the vertical shift. So anytime when you see this form to find the vertex, you don't have to be nervous. Just plug in this formula and you'll find what function you want to get. This has been a Bullis Student Tutor video. If you like this video, please check out the rest of our video channel on YouTube. Thanks for watching.